All right, everybody. So today we're looking at Chapter 2, Closure. What have we learned in this chapter? And so it says the activities below will offer you a chance to reflect about what you have learned during this chapter. And as you work, you're going to look for concepts that you feel very comfortable with, ideas that you would like to learn more about, and topics that you need more help with. All right. And so what you're going to do in your ebook is drop down to part 2. So you're going to skip the poster. And then it says, what have you learned? And you're going to complete each of these problems. So we start here with 2-130, converting the following fractions to decimals and the decimals to fractions. All right, so let's think about how we do 13 divided by 9. So we can do long division here. We're starting with 13. 9 is going on the outside. And then we're saying, how many times does 9 go into 13? Well, it goes in there once. 1 times 9, that's going to give us 9. So we do 13 minus 9 gives us 4. And now we need to bring a 0 down here. So now we're looking at how many times does 9 go into 40? Well, it goes in there 4 times. 4 times 9 gives us 36. Here we get 4. So then we bring down another 0 all the way down here. And then how many times does it go into 40? Well, it's the same thing. It goes in there 4 times. 40 minus 36. Ooh, look at that. It gives us 4 again. So if we brought another 0 down, we'd once again get 9 goes into 40 4 times with the remainder of 4. And so that's why we have a repeating decimal, right? Because we see 4, 4, 4 here. And so how could I rewrite this? Well, I could do 1.4. And then how do I show that that 4 is repeating? Write that line over the top of it, right? That's saying that this 4 here with that line above will just go on forever and ever and ever. All right, so now we're looking at 7 divided by 8. This time, the number that we're starting with is actually smaller than the number that we're dividing it by. So, of course, we're going to start with our number that we're starting with on the inside of our dividing symbol. And then on the outside, we're going to have the number that we're dividing by. So here we have, say, 7 pieces of cake, but we have 8 people who want to eat the cake. So how are we going to divide up those pieces? And so what I'm going to do is, okay, 8 doesn't go into 7 at all. So I'm going to start with 0, put a decimal point after it. Same with my 7, put a decimal point right after it. And now I need to look at how many times 8 go into 70. All right. So 8 goes into 70 8 times. 8 times 8 is 64. So now we need to subtract 7.0 by 6.4. So we're going to get 6 left over. Bring down another 0. How many times does 8 go into 60? Well, if we do 8 times 7, we're going to get 56. So it goes in there 7 times. 8 times 7, we said 56. So here, when we subtract those, we get 4. And then we have to bring down another 0. 8 goes into 40 5 times. So we write that number up top. 40 minus 40, 0. So now when we've reached 0 here, what does that tell us? What is that 0 indicating? Tells us that we're done, right? We don't have to go anymore. This is our final answer up here. And we would call this a repeating or terminating decimal. Well, we said this was repeating. And so this over here would be terminating. It ends. All right. I think you guys are doing really well with those. So then if we move over here to the problems on the right side of the screen, now we're going to write these decimals as fractions. And so here I have 0.204. And I could write this as 204 out of, well, let's think about how many it would be out of. Here, this is our 10th place. And then we have our 100th place, right here. And then this here, the 4, that's our 1000th place. So it's going to be out of 1,000. And now we can think about, okay, is this in the simplest form possible? So in other words, is there something that you could divide both 204 and 1,000 by? Well, I noticed they're both even numbers, so we could divide them both by 2 for sure. So let's go ahead and do that to start. And so up top, we're going to do 104 divided by 2 equals 102. 1,000 divided by 2 equals 500. Well, they're both still even numbers, so we could actually divide them by 2 again. I'm trying to change colors here, and it's just not letting me, You guys have seen that plenty of times in class. It just doesn't let me change the colors when I want. All right, so if we divide by 2, 102 divided by 2, that's going to give me 51. And then 500 divided by 2, that'll give me 205, or 250, excuse me. And I noticed that 51 and 50 both don't have a number that goes into each of them. So this will be my final answer, 51 over 250. All right. And then the same thing with our final one over here. We'll do it really quick. So we have our 10th place, and then we have our 100th place. And so this is going to be out of 100 for my fraction. And then what number do I have after that decimal? 47. So 47 out of 100. Can I reduce it? No, I cannot. That'd be my final answer. Nice job. Now we're moving on to the next one. All right. Suppose that Cecil, the tightrope walker, can only travel lengths of 5 feet, 6 feet, and 8 feet. He can travel forward or backward and can go farther than his ladder and can come back. Show 2 number expressions that represent a way for Cecil to cross a tightrope of the following lengths. Make at least one of your expressions for each length include a backward movement. So when we're looking at a backward movement here, and we're only adding numbers, what type of number, or integer I should say really, is a backward movement going to represent? It's going to be a negative integer, isn't it? That's the only way we can move backwards. Think about when we did that tightrope activity outside with the cones. So we're looking at 16 feet first. So I'm going to get creative here. I'm going to throw some multiplication in my problems. And I'm going to say, all right, we're going to tell Cecil to make 3 moves to start. And in each of those moves, we're going to tell him to go 8 feet. All right? This is just a simpler way of writing 8 plus 8 plus 8. Okay? So I'm going to tell him to go 8 feet 3 times. So there's my multiplication to start. And now I need to throw in my addition. Right now we'd be at 24 feet. And so now I'm going to add negative 8. And so then this would simplify to 24 plus negative 8, which would give us the answer we're looking for of 16 feet. And look at this, we threw in our negative number, or integer I should say. And now we're looking at 19 feet. I'm going to do the same thing. I'm going to start off with some multiplication. So I'm going to tell him to go 5 feet 5 times. All right, so that'd bring me to 25. So then I would need to add negative 6 feet to bring them back to 19. So that would give me 19 feet. And we also have our negative number in there, that negative 6. 13 feet. See if you can come up with one here. So pause the video, see if you can come up with one on your own for 13 feet. Make sure you include a negative or backward movement. All right, so what I did here is told him to go 5 forward 3 times. All right, and so that would give me 15 feet. And then, of course, I'd have to tell him to go back to negative 2 spots to get to 13 feet. All right, and then the last one, I'll leave that up to you guys. So here it says Cecil started from point A and moved according to the expression 8 plus negative 5 plus 7 plus 6, plus negative 7, plus 5, plus negative 8. What additional step would Cecil need in order to return to the starting points? Okay, so if we're thinking about the starting point, that's going to be 0. So based off this equation here, how could I get him back to 0? Well, we'd have to figure out where he is after all these moves. So if I move forward 8, and then I move back 5, then I'm going to be at 3. And then if I move forward 7 and forward 6, well, then I'm adding 13. And so now I'm at 16 after those 2 moves. And I'm looking at my next 2 moves. We're moving negative 7, and then we're adding 5. So let's see, negative 7 plus 5 would be negative 2. So we're going to add negative 2, and that would put us at 14 after the next 2 moves. And then our final move here, we are adding negative 8. So plus negative 8. That's the same thing as subtracting 8. So that puts us at positive 6. All right, so if we're at positive 6, what would our next move need to be to get us back to 0? In other words, 6 plus what will get us to negative 0, or get us to 0? Well, we know this is going to have to be a negative number because we're going backwards. And we also know it's going to have to be the same value as our positive number, right? Same absolute value. So it's going to be negative 6. What we'd add with positive 6 to get to 0. All right. So it says rewrite each of these products as an addition problem and then state the number that the expression represents. Okay, so we need to write 5 times 3 as a addition expression. So it's saying that we're going 3 5 times. All right, so we're going to go 3 plus 3 plus 3 plus 3 plus 3. All right, and this would equal 15, same as what 5 times 3 equals. Try this next one on your own. Think about what number it's telling you that you're going to be moving, and then how many times you're going to be moving that number. Like this past time we moved 3 5 times. So I added 3 together 5 times. All right, so coming back to this, you should have gotten that you're moving negative 2 3 times. So I need to write it 3 times. And here I'm using my parentheses around the negative 2 to separate it from the adding signs. And if we add them all together, meaning we go negative 2 back, and then we back up another negative 2 and another negative 2, we end up at negative 6. All right, now we're looking at 134. George is playing a game, but the spinner is incomplete. Oh no! Help him figure out what the fraction is that he's missing. So here we have 2 fractions given to us, 2/5 and 1/3. And so think about what we would have to do with these 2 fractions first before we can figure out that missing piece. Well, here we have 2 parts, and so we need to add them together. So I can't just add across the top and the bottom. Instead, I have to start by doing what? Finding that common denominator, right? So I'm going to do this in a different color here. I know 5 and 3, if I multiply them together, will give me 15. So they both go into 15. And then I have to change the top numbers here, our numerators, to something out of 15. So here we had to multiply 5 times 3 to get to 15. And so now I'm going to multiply 2 times 3 to get to 6. And now I'm going to multiply, 3 by 5 to get to 15. So I'll multiply 1 by 5 to get to 15, or to get to 5. out of 15. And so now we're going to add our two fractions together that we have found with the common denominator. And we're going to have 11 on top, 5 plus 6. And then we're going to keep 15 on the bottom. Because if this entire spinner is divided into 15 pieces, it's always going to be out of 15 pieces. All right? And then 1/3 right here where I'm shading, that's going to be 5 of the 15 pieces. And then 2/3, which I'll do in green here, that's the 6/15. So if we have those two pieces, what would our final piece be? Well, we know it's going to be out of 15. So we can start with that. And now we need to look at, okay, what would our missing piece be? Well, we can look at how many total pieces there would be if it was out of 15. In that case, it'd be 15/15, right? That'd be equivalent to the entire thing. And then I'm going to subtract it by however many pieces we found so far, which here is 11/15. The two pieces combined. And so when I subtract 15 from 11, that's going to give me my numerator of 4. So 4/15 would be my missing piece right here. All right. Moving on to the next problem here. Multiply 2/3 by 1/2. You may want to copy and complete the diagram below to show your work. Well, it actually has done the first step for us. Because when we're multiplying fractions, we can think of this multiplication symbol as the word of. So you're taking 2/3 of 1/2. Since we're taking of 1/2, here we are starting with 1/2. And that's what we see here in our drawing. This has been divided into 1/2, and this half has actually been shaded. So now we need to do what? What is our next step here? Well, we need to divide it into thirds. So here I'm going 1/3, 2/3, 3/3. And so now I'm going to shade in 2/3. And now I'm going to look at where do my colors overlap. So where does my blue meet my greens? It's going to be right here inside of this rectangle. So here I have 1, 2 pieces. That'd be my numerator. Out of how many total pieces? Let's go ahead and count them up. So we had 1, 2, try and do a new color here. 3, 4, 5, 6. So my fraction is 2 out of 6. Are we finished? Is my problem complete? Or can I simplify this 2/6? Well, 2 divided by 2, 6 divided by 2 would give us 1/3. So this here would be our simplified version of what we see here in this diagram. All right, nice job. Moving on to the next one. Mary has a bag of colored tiles. There are 8 red tiles, 7 blue tiles, 9 yellow tiles, and 12 green tiles. If she reaches into the bag, what is the probability of picking the following? Well, I'm a color coordinated guy, so I'm going to try my best to underline the different components I'm working with here. So 8 red, 7 blue, 9 yellow, and finally 12 green. So now I don't even need to really read the problem through. I have my colors right there. So first off, I'm looking at my yellow tile. So I'm looking at my yellow color, and there are 9 of them. So I'm going to go ahead and start with 9. And then how many greens do I have? Well, there's 12 greens, so I'm going to start with 12 for green. And now I need to look at 12 purple. Or how many purple? I don't have any purple here, and so I can tell you right now I'm definitely not going to have any purples. Not applicable. All right? So now we're looking at how many do we have total? So we'd have to add up 8 plus 7 plus 9 plus 12. So here I get 15 to start. plus 9, I'm going to get 24, plus 12, 36 total. So where do my totals go? I have my parts at the numerators, 9 and 12. Now my denominators, it's going to be the total. Here it's 36, 36. So again, total, total. 9 is a part of the marbles, and 12 is a part of the marbles. So now we're going to look at, can we reduce these? Okay, well, 9 and 36. Ooh, 9 goes into both of those, right? So if I do 9 divided by 9, it gives me 1. 36 divided by 9 gives me 4, 1/4. Nice and easy. Now we're looking at 12. 12 and 36. Oh yeah, those can both be divided by number 2, right? Well, what if I just took 36 and divided it by 12? Maybe that'll work. So what are we going to get here if we do 12 divided by 12 up top and 36 divided by 12? Just get 1/3. Nice. So now we have our probabilities nice and simplified. So instead of someone saying, hey, when I reach into this bag, what are the odds that I get a red? Instead of saying, oh, you would get like 8 out of 36 red, you could say, oh, you'd actually get 2 out of 9 red. Or you could say 1/4 yellow or 1/3 green, right? So it's an easier way to say it than those large probabilities. That's why we simplify. Next says copy the incomplete axes and fill in the missing numbers so that the scaling is consistent. So here we start at 0 and we move to 16. And so we're looking for the missing numbers here. All right, well here we're jumping up 1, 2, 3, 4 parts. And I'm starting with 16. So 16 divided by the 4 parts, that's going to give me 4. So I count up by 4, 8, 12, 16. The next one would be 20. All right, so now you're going to do the same thing for this next problem here, problem B. You're going from 0 to 50 in 2 jumps. So how much are you going up by each time? And then go ahead and fill in the missing hash marks. All right, so what you should have gotten, I'll do this in green here, is that from 0 to 50, I said I was doing it in green, come on. There we go, 0 to 50. We're going up 50 in 2 jumps. So I'm going to do 50 divided by 2. It's going to give me 25. So that's how much I'm going up by each jump. And I'm going to take my blue and I'm going to say 25, 50, 75, 100, 125, 150. Nice. All right, so this is how we scale our axes. And then when we have a graph, how many axes do we have? We have 2. And so you do the same thing when you're scaling your axes for your graph, except you're just doing